Alright, so today we're going to talk about inequalities. So inequalities are equations that aren't an exact answer. There can be more than one answer. So for example, x is less than 3. So since it's not equal to 3, our dot's on the 3 but open, and our numbers are all less than 3. So any number less than 3 works. If x is greater than 3, but not equal to, any number greater than 3 works. If it's closed, like x is less than or equal to 3, then our dot is closed in like that. So it's the same thing, just the dot is closed in. And this is any number less than or including 3. And then, or x is greater than 3 is any number greater than 3, and the dot's closed. So that means it's including 3. So 3 can be your answer, 4 can be your answer, 3.21 can be your answer, any number greater than 3. Alright, so when you're solving inequalities, you solve them the exact same way as you do regular equations, except for if you're multiplying or dividing by a negative number. But we will talk about that when you come back into class. We're actually going to do an activity. So these notes aren't going to include dividing or multiplying by a negative number. Alright, so solve the equations below. So our inequality sign is going to be our mirror. We're adding 2. The opposite of adding 2 is subtracting 2. So we have x is less than, just bring down your sign, 6 minus 2 is 4. So since it's less than 4, not equal to, the dot's open, and every number less than 4. And the way that you check these is that you plug in a number that is less than 4. So I'm going to say x equals 1. So 1 plus 2 is less than 6. Is that true? Yes. So my answer is correct. Alright, the second one, we have our inequality sign. So we're trying to get rid of the minus 5. The opposite of minusing 5 is adding 5 to each side. That zeroes out. We get x is greater than 1. So I put my open circle at 1, and any number greater than 1 should work. So let's test it out. Let's test 2. Oh, sorry, not 1. Messed up. I need more coffee today. 1 plus 5, I forgot to add. So I forgot to do this part of my equation. So let's not forget that part. So 1 plus 5 is 6. So it's any number greater than 6. And because I checked my answer, I knew I was wrong. So any number greater than 6. So I'm going to pick 7. 7 minus 5 is greater than 1. Well, 7 minus 5 is 2. Is 2 greater than 1? It is. And because I checked my answer, I knew I did something wrong. Alright, we have an inequality sign. We have our part that we're solving. So remember, we don't want to worry about this x term first. So we don't want to worry about that part first. We want to get rid of the adding 1. The inverse of adding 1 is subtracting 1. That zeroes out. We get 2x is less than or equal to 11 minus 1 is 10. We're multiplying by 2 here. Divide by 2. We get x is less than or equal to 5. So our dot is closed on 5, and it's less than. So let's include a number less than 5 or equal to 5. I'm going to do 5. So 2 times 5 plus 1 is less than or equal to 11. Well, 2 plus 5 is 10. 10 plus 1 is 11, and it can be equal to it, so that answer is true. Alright, and then let's look at the fourth one. We have our inequality sign. We're adding 7, so we need to subtract 7. That zeroes out. We get 3x is greater than or equal to 19 minus 1 is 20. 19 minus 7, I need to make sure I make more pronounced. 19 minus 7 is 12. We're multiplying by 3 here, so the inverse of multiplying by 3 is dividing by 3. So we get x is greater than or equal to 4. So my dot is closed because it's equal to, it's greater than 4. So let's choose 5. 3 times 5 plus 7 should be greater than or equal to 19. Well, 15 plus 7 is 22. Is that greater than or equal to 19? It is. So my answer is correct.